Welcome again. In this episode of CHeM in 3, we consider these points.
Why is copper sulfate blue? What are complementary colors? What is d-orbital splitting? Let's begin by placing this water sample into a spectrometer. And with the device set to show transmittance, you can observe that all of these colors of the visible spectrum are transmitted, exactly what you would expect from a transparent solution. Now we place a solution of copper sulfate into the spectrometer. Once again, noting that transmittance is on this axis, we see that a very high amount of blue and violet is transmitted, and you can see here that a huge amount of this orange-red region is entirely missing. It is absorbed. To explain this, we first note the electronic configuration of copper, which is argon core 3d10 4s1. And when copper forms an ion, 2 electrons are lost, one from the 4s level and one from the 3d, leaving this electron configuration with the 5 parts of the d orbital containing 2 electrons each and the 5th one containing the 9th electron. When copper sulfate is placed in solution, copper ions and sulfate ions are surrounded by water molecules. These water molecules behave as ligands, donating their lone pairs to the d-orbital system at these 6 points, associating with this vertical d-orbital and this d-orbital that's located in this plane. We should note that there are 3 other components of this d-orbital system which do not associate with the water molecules or the ligands. So here, as the water molecule donates its lone pair and forms a coordinate covalent bond with the d-orbital system of the copper ion, it is described as being a ligand. And because these 6 water ligands associate with only 2 d-orbitals, it causes a split in the d-orbital system of the copper ion, leading to 2 of the orbitals being elevated in energy and the other 3 being depressed in their energy, noting that all 5 of them begin at the same energy level, but 2 become elevated and 3 become depressed. These 2 that are elevated are the ones that directly associate with the 6 ligands. These 6 ligands with 4 on the base, 2 at the apices, form an octahedral shape when joined. And this is why the copper complex is described as being octahedral. When an electron is excited from this ground state to the excited state, the energy that is absorbed corresponds to a wavelength and frequency that falls into the orange section of the visible spectrum. And this is why we say orange is absorbed and blue is transmitted. These colors are complementary to each other. And you can notice that when orange-red is absorbed, that blue-green and blue-violet are transmitted. And this fits in with the observed color of copper sulfate.